Hello, hello. I've got a great show for you today. Edward Schmitz joins me to show off his incredible IoT device. I got to be honest, I got kind of schooled on this one. There's a lot here. It's probably one of our more deeply technical, more electrical engineering style episodes we've ever had in 630 something episodes. So enjoy. The mailbag will be next week. So you have another week to send your feedback to the Discord. If you're not on the Discord, join it. It's just called Coda Radio. So it's pretty easy. And you know what? I'm not going to preface this one too much. Enjoy. Still running your business on last week's spreadsheets? Alice automates your data pipelines, connecting old systems to modern dashboards. Stop chasing data. Finally trust your numbers. Learn how at alice.dev. All right, folks. I'm here with Edward Schmitz of the SigCore project, soon to be released. Open source. Well, I'll let him explain it. Edward, how are you?
Hi, I'm good. It's so good to be here with you today. Thanks for having me on the show.
It's great to have you. So what is SigCore?
Okay, so SigCore is meant to be a complete product, so people can get the job done. It's got PID, Modbus, it's got .NET and Python libraries. It's built with a web interface, so people can get started with it right away. It comes with a software control panel, so it's easy to understand and gives you full control of the device. You can set up your PIDs in minutes and turn systems on and off with a few clicks. You see what your system is doing in engineering units. So, there's no need to try and convert voltages in your head or anything like that. It has calibration for sensors, and it'll log your data, integrate it into other software through Modbus or .NET or Python. It's meant to be a complete controller that is easy to use.
Okay, so let me see if I got this right for people like me who, are a little just not with it. Mm-hmm. Let's say I have some complicated manufacturing equipment, or I don't know, something I'm more familiar with, agricultural equipment, and there's just a bunch of data being spewed out from these machines that I want to collect. I can use SigCore to collect that data, process that data either via .NET or Python, right? Because there's a library for both, you said.
Uh-huh.
And send that to whatever, I don't know, ERP or Power BI or whatever solution I need to send it to?
Yeah, so what it does is it reads sensor signals and digital I/O. So if you have a system that has, several different things that need to be turned on and off, motors, and it's giving you feedback about what's on, what's not on. Plus, you need to do like maybe temperature control or humidity control. So the SigCore will read all of those sensors, and then it provides a PID feedback control. So if you have, let's say you have a temperature chamber, and you want to be able to turn your unit under test on and off. So you hook up the digital relays to be able to turn your unit on. You can control the chamber. You turn the heating and cooling on with a relay, and then you read those sensors. SigCore will read the sensors and then provide feedback control to the chamber to control it to a particular temperature.
Oh, I see. So you can do more than just monitoring. You can actually have it say that I need to be between 50 and 60 Celsius. I don't even know if that makes sense. I'm just making up numbers. My metric isn't very good.
60, 70 Celsius, that's a normal operating range for temperature chamber. It depends on what you're testing, but like one type of application for this would be like if you want to control a vacuum chamber. So you're going to be reading the vacuum level on the chamber and doing things accordingly. You're going to be turning valves on to be able to, you turn a pump on, you turn a valve on, it starts pulling the vacuum on the chamber. You get to a certain level, you open a gate valve, it opens up the high vac valve. So now your chamber is pumped down and it's ready to test. You flip a switch, you hit a button on the screen, and it will open up. It'll start your unit under test, it'll kick it on. Maybe it's got a few different things you can kick on or off or whatever. Maybe you have something that you want to stimulate your product with, a external source, and you control it to a certain temperature. So you can do all of that with SigCore, and it does it in an intuitive way. So if you want to use the built-in control panel for it, you can label all of your different switches. You can say what those switches are for. You can turn on your systems, and then you have an on-screen PID. So let's say you want to control the unit to 60 degrees Celsius. So you punch in the 60. You're giving engineering units, and the system starts controlling the heaters and the cooling, so that the product comes to the right temperature, and then you can start tests. And you can collect data through SigCore. You can see in your data stream. You can see what the set point was, what the actual value coming back was. So you're controlling to like 60 degrees, and it's going 62, 63 down to 59, 58. It's hovering right in there around the 60 degree mark, and you can see that in your data.
So it seems pretty flexible. Basically, I'm looking at the actual schematic here. You've got looks like 8 digital inputs, and I think I see 4 analog inputs. A bunch of relay outputs. I can't count them fast enough.
8.
It's 8. Okay. So what inspired you to make this? I mean, you're launching this yourself on Crowd Supply. It seems like you got quite a lot of traction in terms of you have a Python library already that works. You have a .NET library. I know from just chatting with you that you have a lot of experience in this area. But why specifically this product?
Well, that's a really good question. Over the years, I've worked with a lot of different controllers, a lot of different data acquisition systems, and I've been writing SCADA software. That's supervisory control and data acquisition software. I've been writing that kind of software for over 30 years. And the thing I encounter all the time is poorly written libraries, products that are half a solution. They get you part of the way there, but they don't really solve your problem, and you got to deal with the rest of it. And then also there's a lot of products out there that are bloated, that they do too much and they're too complicated, and you just want to do this one thing, and you've got to learn this whole suite of products to be able to get it done. So recently, I was working with a longtime colleague. I was working on a SCADA software, and I was testing it out on one of his vacuum chambers. And his chamber, it's a bakeout chamber for space systems. So he puts product in there, he bakes it out. He's got to give a report after he's done. And I was automating the chamber for him. And I got one of these little control boards, and it just turns into a science project. You got to add all this extra stuff on top of it to be able to actually use it, because it doesn't come with relays, it doesn't come with calibration or any of that stuff that I talked about earlier. It's just a bare control board. And I said to myself, every single person that approaches this board has to do what I'm doing. And I said, this could be a product. And I got really excited about it because, I've run into this same problem over and over and over again in my career. And so I just said to myself, I can do this. I can make this into something that is usable. And I started with that control board, but I quickly put it aside, and I went for something more robust, which is the Raspberry Pi 4B. And then I started adding on a bunch of chips for being able to do the data acquisition and control. do the actual controlling of the devices inside the board. And I built it into a real robust circuit board that connects to the Pi, and then packaged it. And this is SIG-Core UC, Universal Controller.
Wow, that's really impressive. I do have to ask, just because a running theme on the show. So your friend working in space, is this the kind of project where, would Agent Mulder, would Fox Mulder of the X-Files be pleased? Or very disappointed? I had to give it a shot.
Well, I'd say that he'd probably say that the truth is in there somewhere.
It's you just have to have the right controllers monitoring the right system, and then maybe you find it.
Yeah, exactly.
So, okay, so I know people are going to ask me. So this is going to be open source. It's not on GitHub, but it's eventually going to be a GitHub or somewhere else, but eventually out there somewhere, correct?
It'll be on GitHub, and it will be on GitHub soon.
Right, but right now, as of now, if people want to start fooling around, the Python library and the .NET libraries are ready to go for folks to, I guess, write their own applications on top of, right?
Yeah, you can use the built-in software. You can use the libraries to connect it to an existing system. And, it also has Modbus, so that makes it easy to integrate if your system uses Modbus. And, they can start taking a look at it right now. And there's a lot of information on my website. It's sigcoreuc.com.
Yep, and I'm going to throw all those links in the show notes to people, so you don't have to rewind and try.
Okay.
All right. Well, that's all really good. So I have one silly question that I always end these interviews with.
Okay. Good. Sure.
Just anything but tools you make. What is one tool? I mean, a lot of people say like coffee related tools or tea related tools. A lot of people say coding tools, whatever. One tool that you can't live without.
My multimeter.
That makes a ton of sense given what you're doing.
Yeah.
All right. Well, Edward, it's been awesome having you on. I have to say, I need to learn a lot more about this stuff. So I'm having a good time with my BeagleBone boards. And
all right,
this is amazing. When do you? I know estimates are hard. When do you anticipate this being kind of generally available?
I expect to launch sometime in maybe late October to mid-November.
Oh wow, so that's pretty soon.
Yeah.
Oh, okay. Wow. Okay. Well, then I'm going to pick one up just to see what I can do, if anything.
Okay, good. Yeah. So it's been great talking with you, Michael. Thank you very much, and I'm glad to be here.
All right, great talking to you. Have a good day.
All right, thanks. Bye.